Recorder. All right, it's recording. That's all good.
Good morning, Professor.
Good morning. Right. So let's go ahead and get started.
I know. Don't make it twice as long as this.
Does it work?
Yeah.
All right. So I can see that you guys most of you seem to be happy that I'm assuming you got the homework assignment done, or at least understand how to get it done. And I worked on it last night too. I started at about, I would say about 10 o'clock or so. And then I worked until maybe 1 a.m. And you guys may think, Tech, if it takes you 3 hours, it is just way too much for us. And you are absolutely right about that. except for one thing, I read my own homework assignment wrong. I'll show you that's why.
He said, you're right. If it takes you 3, it'll take you a life.
No.
Yes, I read my own homework incorrectly, and I'll show you what my misinterpretation and why it took me so long.
That's like me. My first time around, I forgot to apply De Morgan's law.
Oh.
So I had to redo it on Tuesday.
Well, I had some mistakes, along the way.
Yeah.
Okay, so I'm gonna show you guys how I did this because there might be some tools that you find useful. No, not here, not yet. Okay. Okay. So being the person who came up with the homework assignment, I decided to kind of work on it a little bit, just to say, okay, yes, I know how to do this, right? And then some of you may see it, this and go like, that doesn't look like my homework assignment, right? Because there's one more column. You guys only have x0, x1, and this one has x2, y2. So it's a 3-bit adder, not a 2-bit adder. And you might think, oh, well, then it's like 50% more difficult than mine, right? Well, just look at the R equation.
Kind of scary.
The R is the scary part. The C is not as much. Okay, the C part is actually not too bad, but it's the R part that is hairy. So last night, I decided to work on this, and I decided to pick on something that's difficult to work on first, because I like to get the difficult stuff out of the way first, and then just the easy stuff, I can, because my brain power goes down as time. I need to pick on the heaviest lifting has to be done first, right? So I picked on C5, the cell, to work on that one first, right? So I worked on it using a text editor, okay, because I said that I would use some tools to do it, so I just use a text editor to do it. And this is the easy one. This is the ugly one. This is the actual ugly one. And then at some point I decided, hey, I cannot track this stuff anymore. Okay, the stuff that I cannot track is the multiplication, or when you multiply out stuff like that.
Yeah.
Oh, no, hold on a second. This is the hairy one. This is actually the hairy one. So this is the hairy one. And you can see the problem is because it has x2, y2. So that makes it a lot more difficult because I have to negate the other side and multiply it and stuff like that. So the fun began once I applied all the De Morgan's law is not a problem. Okay, De Morgan's law is really kind of, there's a certain set pattern to it, and once you understand it, it's really just pretty easy to work out. The difficult part has to do with using the distributive law on something like this, and then that. And you can see the scroll bar, right? It keeps going on and on and on. This is the end of that.
This is what you made them do last semester?
Yes.
Are you? They would have been. I worked on just
How many?
6 hours.
Right.
So I can't imagine doing that.
But I did not. But after a while, yeah, go ahead.
How many people dropped after this assignment?
Yeah.
Not a whole lot.
Is it not a whole lot?
How many people got A's?
Not a whole lot. Sufficient, but not a whole lot. How about that? Okay, so anyway, so after a while, I decided, hey, I cannot mentally track all this stuff because I made a few mistakes and I caught myself. Because I knew that, between the x and the y, they should be symmetric. Because addition is commutative, right? So when I look at the outcome and I go like, hey, this is not symmetric, there's definitely something wrong with it. So I trace my way back and go like, oh man, I made that mistake, because I forgot to copy a knot somewhere, and it just, and then I did not catch it early enough, and then it just went forward and go like, oh man, this is not working. Delete a whole bunch of stuff, go back, do it again. Okay, I missed something else. Okay. And to go back and do it again. So at some point I decided, hey, I cannot track this stuff just mentally because I copy things wrong. So that's when I started to look into the possibility of using a spreadsheet, and this is what you might find useful for your homework assignment, okay? So I decided to use a spreadsheet. So at some point I look at one equation. So let me zoom in a little bit more so you guys can see a little better. So not x1 is one term in a disjunctive normal form already. So one term is not x1 plus not x0 not y1 plus not y0 not y1. I'm talking about the top row, okay? And then the other equation has, the other expression has not x0 plus y0 plus not cn plus not x1 plus y1, okay? So, but I have to make the cross product of those two because of the distributive law, right? Okay. So instead of coming up with all these things manually, I decided to go like, hey, a spreadsheet can do this. So I used the concatenation feature of a spreadsheet to do all the concatenation. Now it doesn't do the sorting, so it doesn't really move the x1 first and stuff like that. But I can do that part relatively easily without making a whole lot of mistakes. Okay. Once I can see the conjunctive form, I can do the rest. So the way I do this, okay, this you might find useful because I'll just delete this and show you how I did it. Okay. So I look at all these terms, and I look at this term here. Now see how this one has not x1, and there's also a not x1 here, right? What that means is not x1 and not x1 is going to just not x1. But when you have one term that has not x1, the other terms will all have not x1. But because we can simplify, so the entire column is just not x1. So that's how I can just do it and go like do the simplification at the same time, and just say that the entire column B reduces to just not x1. Now let me just do it once. Okay, when you look at these 5 expressions, okay, they all start with a not x1 because they all use column B. They use the cell B1 as the first component. So it's not surprising that they all start with not x1. Is that okay? But that's not how I can really simplify the whole thing. The way I simplify this whole thing is because when you look at B5, it has not x1 because both the column and the row specify a not x1. So that one is easy, right? Not x1 is just not x1, okay? So once you have this one being not x1, the other ones can now be eliminated because they're all more specific versions of not x1. So that's how I can just look at this whole thing and say, oh, they're all going to be not x1s or zeros. But in either case, oh, okay, the spreadsheet is getting smart, but not in the right way. Okay, do not warn me. I know what I'm doing. Okay, there you go. So this whole column is done, okay? So I look at the next one, which has not x0, not y1, and I look for these things. Do we have another not 0? Not x0? Yes, we do have one. So this entire thing, I don't need to do a single thing about it. I just say this entire column is preserved, just like that. Is that okay?
Of course.
Yes? No? Sort of? Okay, I'll just point out exactly which one I'm talking about. Look at this term here. It is not x0, not y1, not x0. Now the two not x0s we can move them around so they're right next to each other. Then they collapse into just one single not x0. But because not x0, not y1 is the first part of every single expression in column C, right? So that means once I get one single cell of this column to just not x0, not y1, all of the other cells are just more specific versions of this. But because they're all in a disjunction, the more specific terms do not mean anything because you already have a more general term, so the more specific terms can be removed. So that's why I can just look at this and collapse the entire column to one single value because they can all be reduced to just not x0, not y1. And then I look at the last one and say, okay, is there anything in common with the columns? And the answer is no in this case. So this is the only column that I actually have to work a little bit to find out what it's supposed to be. So the first one, there's nothing you can do about it because not x0, not y1, not y0, and not y1, they all have to be here because they are all on different pins. These two are two different pins compared to this one, so there's no way I can actually simplify it right away. Now maybe later, but not right away. Okay, and then the next one is a 0 because I can see there's a not y0 here and just a y0 here, so it reduces to 0. So I don't need to copy it. The next one, there's no way to reduce it, so I'm just going to copy it here. So it's going to be not y0, not y1, and not cn. This one I cannot reduce either because x1, y0, y1 are all different pins, so there's no easy way to reduce this one. So I'm just going to copy here. And then the last one is also a 0 because we have not y1 and y1 in the same conjunction, so they're all zeros. So I look at these two and say, okay, we don't need to include these two. Yep, go ahead.
So can we simplify C6
Yep.
and...
Yep, we can do that.
Oh, okay.
So now you look at these remaining terms and say, okay, do we see anything that can still be used to reduce? And then you look at not x0, not y1, and say, hey, this is a more specific version of this. So you say, okay, we can get rid of this. And then you look at these two. Nope, cannot reduce. This cannot reduce. And then because we have not x1 here, and this one also has not x1 here, get rid of that. See, there's a not x1 here. This one is a not x1 and blah, blah, blah. So we can just get rid of it because it's a more specific version of not x1. Yes, go ahead.
So this trick works only because it's E and F, right?
Because it is E and F, right. Yep, go ahead.
This is essentially like the A plus A times B, where you isolate the A and it's 1 plus B.
This is all based on the reduction of when you have a more general version and you have a more specific version in the disjunction, you can get rid of the more specific versions.
Both terms have that same one A value.
Yeah. He said the example where you have A multiplied by something and then
Right.
it reduces to just A.
Yeah, so when you have A plus AB, okay, whatever A is, whatever B is, doesn't really matter. You can always re-express this as A, and then you have a 1 plus B, right? Because the 1 is the identity for, okay, I'll just spell this out.
It's factoring out the A, yeah.
Yeah.
That's what you did on there.
Okay, is that part okay? Is A the same thing as A and true?
Yeah, I guess.
Okay, anything and true is preserved, right? So then we can factor it out. So it becomes A, and then A plus 1 plus B. Is that okay? But 1 plus B, anything or true is true. Or I should say true or whatever is what is true, right? So now this becomes A, and then just true itself. But A and true is just A. So that's how this works. So when you have a general version, which is A, and a more specific version, which is AB, in the same disjunction, you can get rid of the more specific terms without changing the meaning of the expression itself. And by using this mechanism, I don't have to go through the manual process of copying all the different terms. I do have to reorder things in my head just so that they look right and it's easier to compare. But I can save myself a lot of trouble by using a spreadsheet to do some of the heavy lifting. Not all, but some of them. Does that make any sense? Yep, go ahead.
Just out of curiosity, if we were doing CNF, conjunctive normal form, then we can get rid of the most general terms since we need the most specific one, and
That is correct, because when you have a conjunction, then you're looking at the intersection of the two sets, where one is a subset of the other one. But when you're looking at a disjunction, you're looking at the larger, the superset of, when you have a superset and a subset.
I'll show you that at 440.
No, that's sequence.
But it works out the same way. The equations are about the same. So what he's talking about is when you have A times A or B, okay? Okay, so then you can apply, kind of the same thing. You can say, the first one is A plus 0 times A plus B. Now in a Boolean algebra, you can do the reverse of this also, so you can basically factor out, what was I about to do? You can factor out the 0, so you can basically factor out the 0, and then you can say this is A times 0 or B, and 0 or whatever is whatever, because, that's why I chose to use 0 to mean false, because the algebra works out the same way in most cases. So this reduces to just AB, which is basically the more specific term in this case.
I don't know if you just mentally do this step, but when you would distribute that, wouldn't you initially have A times B plus A times A plus A times B? Because when you distribute like a term and the operator.
Okay, with this one, it started off as with the more specific term, which is A.
Yeah.
No, I take it back. You have right. You have A and then AB, A or AB, the same way. I have to think about this. We have to keep the more specific term.
This would expand out.
I think this part is wrong. I got this part wrong.
This would expand out to A plus.
I got this part wrong. Okay, so let me reverse this. Yep, this part is wrong. I think it should be.
This is that, right? Just expand out to that.
There we go. That makes more sense now.
And then, yeah.
Because it's using the other distributive rule in Boolean algebra.
Yeah, which is the term and operator.
Yep. But the end result is you keep the more specific term in the case when you have conjunctions.
So in that case, should we have kept A or B?
You should have kept A, but not A or B. Because
So,
A is more specific than A or B.
I'm not sure if it starts out like that, and then when you end up doing it, you end up just doing what we did before, which is you'll pull out the A.
Correct. But this is the we're using the other distributive law in Boolean algebra. Okay, so, but this is not the end of it either. So you can see all the other sheets, okay? So I take these 4 outputs. Okay, are they exactly 4? Yep. Sorry? Oh, because I can get rid of this. So I take these 3, and I put those here. Obviously, I forgot to factor that one out. But it's okay. It's not wrong. It's just that I have to do some extra work later on. But then I use these 3, and then these 5 terms are coming from the result of another De Morgan's law. So I keep doing this. I take the result, I simplify everything. So I take this and take it onto the next sheet, so it becomes the row here. And this is another expression from the original big chunk of expression. So I keep doing this until I get to this part. And that part. Then I go like, and then it was 1 a.m. already. I was thinking, well, I should probably hop onto the exercise bike for half an hour. Then look at the time, go like 1 a.m. Probably not, because I have to wake up at 6:45 to drop off my kid. So that's when I stopped and go like, okay, I think I'm good. And then when I woke up this morning, I just realized, oh, we only have x0, x1, y0, y1. I was done a long time ago. But I decided to work on the 3rd bit, which you guys do not have to work on.
Well, thank God.
Okay, because I saw a few kind of concerned faces. It's like, that didn't look like my homework assignment at all. No, because I did it wrong. I did not read my own instructions correctly. Okay, so, but getting back to your homework assignment, it's already done here. Okay, so if I switch back to the text editor. Yeah, this one I can work out. Yeah, this is actually your Z1 or bit 1 of the result. So this one I can work out without the aid of a spreadsheet. So it boils down to something like this, okay, which is not nearly as bad as the other one. Is that okay? I mean, does this help you guys kind of understand how to work on this a little bit?
I spent like 15 hours and I did the second part like 11 times, and I got different answers every time. Like I have no idea how to do it.
Well, I did the same thing last night, you know, because I can cross-check my own answer and go like, no, that doesn't make sense. It should be symmetric, and I saw something that's not symmetric. So I trace my way back and go like, why is it not symmetric? This step looks right to me. Okay, moving on to the next one. This step looks right to me. And then this one has, how come there's a C in and there's a not C in? Darn, I forgot to copy the exclamation point from the previous line. We're like, oh, okay, now I delete all the lines below that and then start over again. So at some point I realized if I rely on myself, you know, just copying and pasting and just typing, I'm just going to make mistakes. So,
I like started from scratch 11 times.
11 times?
11 times.
So what you need to do is to find out, be able to track backwards and find out, you know, at which step you make a mistake, and then just only restart from that point, and not all the way to the beginning.
I think I need help. Like it's the only thing I can say. Like I need actual help. There's no way that I can proceed without understanding this bit, without understanding like how to do the math on this. There's no way that I'll get anything else.
Okay, but one sanity check is whether the x and the y's are symmetric or not. Because in any addition, it is commutative, right? So that means if you just switch all the x and y's, you know, the terms should be there. Okay, let me illustrate what I mean by that. Okay, see how this term here has not x0, x1, and then not y1? I should be able to see the exact opposite of this. You substitute all the x with y's and all the y's with x. So I should be able to see not y0, y1, and not x1. Okay. So let's see if that's there or not. That's kind of like a sanity check. Okay. So we are looking for something that has a y1 that is not negated. So y1 that is not negated. There are a few. And I think this one is the flip side of that one. Okay. Nope, it has an x0. Uh-oh, that doesn't look very good. It is not symmetric. Now, you know, but that's a sanity check. If it's not symmetric, you know, that means, you know, I might have made a mistake earlier. Now, when you are done with your design, okay, so let's look at these things and say, okay, what does it mean? What am I looking at here? This pattern here means that anything that fits this pattern is going to end up with a 1 as Z1. That's what it's saying. Okay? Well, you have to say, okay, does it make sense? Okay? So and there are only like, what? About 9 of these, okay? So we can check all 9 to see whether they make sense or not. So what I'm doing here is now I look at the pattern, okay? I look at the addition pattern, and I'm going to do this part on the whiteboard here just because I can't really show this and the screen. Okay, do you guys have any questions?
I was talking about the homework, how we had, I had like 16 different ways to forget it.
I had 17.
I didn't want to I didn't want it to have to deal with it more than once.
Okay.
Because I didn't want to go back and change it and make messed up.
Okay.
Because I did like a truth table and I did like all down.
Okay. You can certainly do it that way too. Use a truth table. Yep.
So is there multiple ways to get the right answer for this
Yes,
assignment?
there are multiple ways to get the right answer, and the way it is expressed can be different as well. Okay, so I'm going to do a sanity check on this one. Okay, so let's see what this means, right?
I think I got it
We
down.
have x0, x1, y0, y1, and then we have a carry in here. Okay, and we are talking about this is z1, which is this bit here. So we are talking about this particular bit. So let's see if each one makes sense. Okay, so the first one, okay, I'm going to highlight on the whiteboard here. So I'm checking the sanity of this one here. The sanity of this one basically says I have a 0 here. Okay, I'm just going to write it over here. So we have a 0 here, and we have a 1 here. Okay, these two are the x bits. How do I know that? Because when you look at the expression, it says not x0. What can make not x0 true? X0 has to be false, which means that it is specifying a 0. Therefore, we have a 0 here. Yes?
So this is for Z0?
This is for z1. This whole equation is for z1, not z0. Z0 is a lot easier.
It's like
Yeah.
just the result.
Right. What about y? What is the pattern of y? The only thing I have to make sure in y, or y, the number y, is y1 has to be a 0. Because when y1 is a 0, then not y1 is a 1, and that makes this expression true. Okay? So we want to make sure this is 0. This is unknown. I don't know what it's going to be. And it doesn't specify c in either, so c in can be a 0 or a 1. So the question is this pattern guaranteeing that this result here is going to be a 1? And I can see has turning because it does not. Because if this is a 1 and this is also a 1, then you end up with a 0 here with a carry. But with a carry here, we have 1 plus 0, which is a 1. 1 plus 1 is a 0 with a carry. So I know that expression is incorrect.
So that's where you made your mistake?
I made a mistake earlier.
Yeah, that's like where the code, where the debugger tells you on line 45, but it's really.
Yeah.
Oh, okay.
But in this case, because I kept all my derivations, I can trace my way back. Okay, so the previous one is this one, so this term is already here, and I have to go back to this one. It is already here, and it is here because of.
I don't know how you're saying anything other than mush. I said how you're saying anything other than mush. That is amazing.
It's here because of using this guy on top of that. Okay, I did not copy incorrectly. So you basically have to do something like this to trace your way back and find out where did you make that mistake. So what is going to be an obvious way to fix this one? One of these question marks has to go. One of these question marks has to become a 0. Then you can say, oh, if this one becomes a 0, this can still be unknown, and I can still guarantee this output to be a 1. Or the other way around, I can specify this one to be unknown, this one to be a 0, and I can still guarantee the output to be a 1 for Z1. Okay? But I have to go back to my earlier steps and find out where I made that mistake. I'm basically forgetting to include some extra terms to get it to work. Is that okay or not?
Are you recording sound today? Because on Tuesday.
It's good to check, yes.
It was hilarious watching it, and it's like, oh, and now we have sound.
Yep, we do have sound, yes. Yep, I am recording the audio. So let's go back to this one, because I want to show you guys, okay, I made a mistake. What am I going to do? Do I restart everything or not?
Well, you can do it.
Okay, so I'm showing you guys how to debug your design, because this is how this is a sanity check, okay? I'm just picking up some expressions and saying, okay, does that make sense? Does this condition guarantee a 1 over here? And the answer is no, it does not. So we have a problem. So if there's a problem, we have to go back and fix it. Yep.
I mean, that works for like one little bit of it, but if I've got 38 terms, I can't do that for every little piece.
If you have
of
38
every
terms, that means you're not simplifying in the process.
Then I don't know how to simplify that. Because I don't know how to
Probably
simplify it
true.
until it's just like until it's really, really long, and then I can say, okay, this one's the same as that one. And
Are we talking about R1? I mean Z1?
We're talking about
Yeah.
the second one. B.
Yeah, that's
Yeah, Z1.
The
Yeah.
most significant bit
Yeah.
of the result of the addition, right?
Yes.
Okay. So let's go ahead and just work this out in today's class, okay? Because I just want to show you guys how to apply all of those rules, okay? Yep. There's a hand. Yep. Go ahead.
I just wanted to double check on the way you wrote 1, 2, 3, 4, line 5, where there's no more R. Isn't R defined as A not B or B not A, right? But I see A not B there. Do you ever do B not A?
You mean this line here?
Yes.
Yeah. I see what he's talking about.
Oh, it doesn't have the second part.
No, it does not. Maybe that's why.
That is. Definitely, that can be a problem, right there.
Is it off screen maybe?
Hmm?
Is it off screen maybe?
Nope, not on that line.
Uh-oh.
Okay. Oh, you're right.
They both don't work.
There we go. That's the rest of it. That's the rest of it because I have to line up everything so I can check, easier. I have to line things up. Okay. Because I was thinking, that would be kind of an obvious mistake.
Yeah, the white space and scroll bar.
Okay. But I do make mistakes like that occasionally, so good to check. Okay. So what I did here was the first thing I did was to expand all the inside ones first because they're easier to see. So this R x1 y1 becomes x1 not y1 or not x1 y1. Is that part okay? Okay. And then I look at C x0 y0 and that becomes just x0 y0 because that's the way the carry bit works out. It's just a conjunction. Is that okay? So the way I do this is I do it step by step and I line up everything so I can see. So this one is R x0 y0. It becomes x0 not y0 or not x0 y0. Okay, that seems to be correct, right? Okay, so I only do one thing at a time or apply one particular thing at a time. And you can see how they line up. Okay, they line up so I can check more easily. So I can go back and check and say, okay, this step is okay. So the next line here is to apply this last C because C or the carry function is easier to apply because it really is just multiplying stuff, right? So in this case, we use the distributive law and say, okay, let's combine this with C in. So now we end up with x0 not y0 C in. And then we say, okay, let's apply the same thing to the other side. So we multiply the C in to this term here, and it becomes not x0 y0 C in. And that's the whole purpose of the second line of the derivation. The third line, which is this line here, and can anyone tell me what I did with from the previous line to this line? Yep, go ahead.
Drop some parentheses.
Yeah, I just dropped some parentheses because they are no longer needed. Okay, because the parentheses are just kind of indicating nesting that is not needed. Is that okay?
Yes.
And then the next one is to apply the R, which is the hairy one, because okay, I have to show you guys how I did it. The way I do the R is I do the template first. So I do something like this. That's what I do first. And then what I do is I say this is the first argument to R. So I say copy, paste, paste. This is the second argument of R. Copy, paste, paste. That's what I did to get it. So I cannot make mistakes in the process. I work on the structure first, then I backfill the content inside the structure. Does that make any sense? Okay. So this is not something that you can easily do when you're doing it by hand, and that's why in class I suggested to use a tool like a notepad, or some kind of text editor to really help you out in this process. Okay. So after this expansion, I lined up everything in the next line, just so that they all look about right. So now I can focus on one particular part, which is this thing here. But I can't do a single thing until I apply De Morgan's law to just this part here. Is that okay? So when I apply De Morgan's law, this is what I do when I apply the. Oops. Yeah. So when I apply De Morgan's law, the way I work on this is I copy and paste, and then I work on it, and then I say, okay, I want to apply De Morgan's law over here. So I first get rid of the thing that I'm trying to replace because of the application of a particular rule. Then the De Morgan's law, is in this case, is changing everything to the negation of all the things inside. They have to be negated, and then the disjunction has to be turned into conjunctions. Okay, so I know that I end up with 3 terms, and they're all connected by conjunctions. Yep.
With Morgan's law, disjunction turns into conjunction, right? But it doesn't work the other way.
This is where not
Say one more time.
So disjunction turns into conjunction with this conjunction.
It works the other way as well. Yep. So in this case, then I can just do a copy and paste. And this is literally what I did when I work on this at home. I just copy and paste. Now you can use a mouse, and depending on your gaming skills, you might be able to do it faster than me. Because some of you have much higher precision when it comes to pointing and clicking because of your gaming experience. All that CSGO is helping you do your homework assignment. You can tell your parents and say that I can do my homework faster because I play CSGO. Now I need to get that. Now I need to get that 10,000 DPI gaming mouse to do my homework.
Yeah, exactly.
Yep. I can't do this with the regular.
No, not really. You cannot quote me.
Look, Microsoft Word just doesn't work.
Okay, so now that I have this stuff here, I need to apply De Morgan's law one more time because the negation is on the outside of the conjunction. So I have to distribute the negation to the inside, change the conjunction into disjunctions. So there's no really fast way to do it except to copy and paste it and just work on each item individually. Okay. So you just get rid of the negation on the outside. And the way I do this is I just do it mechanically. Yes, I know double negation can be simplified, but I do not do it in the same step, so I can see it. Okay. Oops. Go back to here. So I just distribute the negation into the inside, change all the conjunction into disjunction. Yep.
So can we simplify it because we have a not CN and a not CN? Or is that a different, simplifying a different step?
You mean this part here?
Yeah.
Well, it's a conjunction, so it's just.
No, you cannot. You cannot simplify just yet.
Not yet. Okay.
Yep. So I look at this, I go to the next step, and then I get rid of all the double negation. And this is all that I do in the second step. Just so that I don't do too much in one single step in case I want to double check and go back. This is how I can double check without having to spend a lot of time. Is that okay? So what I'm doing is not telling you that you have to do it this way. I'm just showing you what I find to be effective for myself. You all have to walk your own paths. Okay, so now I can go ahead and expand all of these things out, but I do not expand everything at the same time. Because if you expand everything at the same time, you end up with 2 times 2 times 3 times 3 terms. And that's just, I cannot track that. Okay? Yeah.
I think I found your error. Like on the line right before the loaded cursor, over here that X zero should be a not X zero, shouldn't it?
No, he distributes it later.
So distributors.
Since you had a not X zero in our current error.
Which line are we talking about? Let me see if I can turn on line numbers in the editor. So view line numbers. There we go.
Line 24, the last term over X0, Y0, CN should be not X0, Y0, CN.
It should be. That's correct.
Oh.
There's a copy problem. Right there.
Right there.
This one?
Look up at line 19.
And compare.
Ah, okay. Very good. I forgot to copy the negation of X. Yep. Yep. So when that happens, what I do is I just get rid of everything below that because because it's really hard to salvage it, right?
It's messy that.
But when I go back and double check, you can see how I can double check each step relatively easily because I don't do too much from one line to the next. So I can retrace all my steps and go like, okay, is it making any sense? Am I missing anything? And everybody has a favorite mistake. Mine is forgetting to copy an exclamation point. So I'll be looking for those, specifically. I made that a few times when they work on the monster expression thing. And going, this doesn't make sense. It's not symmetric. I have to go back and darn it, I forgot to copy that exclamation point. Or simplify when I'm not supposed to. Okay. So, do you guys want to kind of work on this a little bit more or not?
Yeah, because I'm still, so far what you've done, I'm like, done all that.
Okay,
But
so.
somehow I just end up, at some point, something gets screwed up.
Okay, so this is where a spreadsheet can come in handy, okay? So I want to share with you my spreadsheet. Okay, so this is my little cheat sheet, spreadsheet thing, because what I do is I express, the terms over here and the other terms over here. So in other words, this is one conjunctive normal form and this is another conjunctive normal form, and I want to look at the cross product, of these two. And then the cells is just using a string concatenation so that you can do all the concatenation automatically. So let me kind of show you how that works. So I'm going to work on a new sheet here by copying the stuff that I already have, okay? And I have to go back to here just to see what the expressions are supposed to be, okay? So in this case I'm working on, okay, let's say I'm working on this particular cross product, okay? If you only have 2 terms times 2 terms, most of the time you can track it manually, mentally. But if you think, okay, I don't want to do it manually, I want to have a way to systematically do it and be able to trace it back and not have a problem, you can just do it with a spreadsheet. So we have x1, not y1, and I would suggest just to copy and paste it. Just like that. And then come back here, copy, paste, and then go back to here, copy, paste, it's already there. And then the same thing over here, copy, oops, paste, there we go. Okay, so I want to explain the formula just a little bit here. When you look at concat, or if I double click it, it will use color coding, which makes it a little bit easier to read. Is this cell B2 is the result of concatenating B$1, which is basically B1, and A2. So it's combining those two, to become this particular cell. But the dollar signs are very important. Yep.
I was going to say, don't they make sure that when you copy to all the other cells, it doesn't change the 1, it only changes the B?
Correct. Without a dollar sign before a letter or a digit, it will shift depending on what cell you're doing. But with a dollar sign, that becomes a constant. It doesn't shift anymore. In other words, in this case, I want everything to use the same column, and then with A, I want everything to use to start to use column A. For B, I want to stick with row 1. Okay. So with that in place, I can just copy this like this, and then copy it down here. Now I have all the terms. Okay, let's double check, make sure that makes sense. Okay.
It's like cheating right here.
So once I have this, I do not modify this, okay? This is the result of the spreadsheet doing the concatenation. Now, what if you guys say, well, I don't know how to use a spreadsheet? What do?
Watch the video.
You can watch the video. No, you have other tools. What is the prerequisite of this class?
Write some code.
cisp360. And what do you learn in cisp360?
Superstar.
Not spreadsheets.
You tell me what tacky did.
You don't need to know stinking C to learn how to use a spreadsheet. Okay. Okay. So what do you learn in cisp360?
How to write code.
Regular C, C++ programming, right? But did you learn how to use strings in that class?
Yes, you did.
Okay. Did you learn how to use string concatenation? Did you learn how to use arrays?
No, it's not.
Then you have everything that you need to crank out this kind of thing using a C program.
It takes you 25 minutes to write a C program.
You just write a C program, exactly. You write a C program where you feed it, the rows and the columns, and it will just print out the cross products.
You gotta figure that one.
I use it.
Now I know it sounds like a homework assignment inside a homework assignment, but that's what you do. But this is what you do if you think that you can utilize a tool to help you in the process, you make that tool. I mean,
Yeah.
yep. If a sharper stone makes a better spear, you make a tool to sharpen the stone. I mean, that's how it works in computer science. All right, so I just want to keep going with this one a little bit here. So what I do next is I look for ways to simplify. Okay, so to simplify means if you see a term and the negative version in the same thing, then you can just take it out because they cannot coexist, right? So in this case, let's check. Okay, this one cannot be simplified anymore. So we'll just kind of rewrite it by reordering things. I like to reorder things because this makes it easier to compare later on. And then with this one, I just have to be very careful not to miss anything while I'm copying. And then this one is x1, not y0, not y1. And then this one is not x1, not y0, y1. There we go. I don't think we can do any simplifications because they do not share any terms. Okay? But that's okay. Not a big deal. All right? So what do we do next? Well, we open a new sheet here, and then it's up to you to decide how you want to do this part here. If you really hate copying and pasting, you can use the new sheet and just say that this cell is this cell in the other sheet. That works, okay? And you can do the same thing over here. So the idea is to copy all these terms into the second sheet here. So we can refer to this one. Now, this method is going to mess up if you change the position of things, okay? So you have to be careful when you use this little shortcut here. Okay, so what do I put here?
You gotta go back to your
Notepad? Yep. So I go back to my notepad and I go like, okay, let's deal with this one because I'm done with the first two. So now I work on this one. So I will just do a copy and paste because once again, I do not want to make a mistake in the process. So yeah, go ahead.
What if you just do both of those terms, the right side now of this?
You mean these two?
Yeah.
Yeah, these two look like they can do a lot of simplification because one has x0, the other one has x0, one has y0, the other one has not y0. So it looks like you can do a lot of simplifications. Yeah, so you can reorder the combination just to maximize the canceling effect to reduce the number of terms. But I'm just doing it sequentially, which is just kind of, I'm just digging my way through. But that's smart because you can identify and say, okay, it looks like there's a lot of canceling between these two. So if you perform that cross product first, then you end up with very few terms.
That's what I did.
Yep, that's a good idea. But I'm just doing it kind of like the kind of more mechanical way. So this way I don't.
This is easy. You just gotta be familiar with that.
All right. So now that I have copied all the terms, there are 12 terms in this case. So I'm hoping that we can cancel some of those. But the thing is, I don't have to do much when I look at the concatenation because the concatenation is already done with the tool. What I need to do is to look for ways to simplify, to cancel things, to do that sort of thing. So when I copy into the second part, I can see, okay, so now I apply the trick that I mentioned earlier in class. So when you look at this term here, it has not x0 in it, right? So that means this entire column also has the same sub-expression. Is that okay? But when you look at this cell here, it has just not x0. So when you combine these two to become this one, it's the same thing as this because you basically just see that, can't do that. You can see that not x0 is reappearing twice. So that means this entire column is simplified to just the original thing, which is not x0, x1, not y1, okay? Because we have, this is the more general term, everything else is a more specific term. Yep?
Isn't just not x0 the more general term?
Yes it is, but you can, there's no, no cell in here simplifies to just not x0, so you cannot just have that.
So you could even simplify like B3, because there's a Y0 in there.
Yep.
That doesn't matter.
It doesn't matter because the Y0, okay, this Y0 is, no, but the Y0 has no way to combine. Okay, let me just work this out. Okay, so if I don't simplify, I just copy this one, right? So we have not x0, x1, y0, not y1 here, right? But when you look at these two, this is the more general form of this one.
So Y0 won't even affect it?
Like, how do you know it's
Because it, sorry?
How do you know it's the more general? Like, is that,
Okay,
how do you know, what makes that one different?
okay, what about this?
Y0?
What about this? I just moved y0 over here.
If you let not x0 be true, x1 be true, and not y1 be true,
Then
in
y-
both scenarios, regardless of what y0 is, the entire expression is true because the top one is always true.
Okay, the way we know which one is more general is basically we ask this question. Okay, first of all, are they connected? The answer is quite obviously they are connected, they're related. Because the first one only has 3 terms in the conjunction, and then the second one has 4 terms, but of which the first 3 terms are exactly the same as the first expression, and it has 1 extra term, right? Okay? So then you ask the question, okay, which one implies which other one? If I tell you this one is true, does it automatically mean the other one is true? Okay, so we ask the question. If I tell you this one is true, does it imply the other one is true? Yes, it does. Does it work the other way around? If this is true, does it automatically imply this one is true? Nope. So that, because this one doesn't take y0 into consideration at all. This one is true as long as x0 is true. Excuse me. If x0 is false, x1 is true, and not y1 is false, then this whole thing is true, regardless of whether y0 is true or false.
I canceled some terms out that way, but some I left because I wasn't sure if we.
If you leave the term, it's just going to make it longer and more complicated, but it
it'll
doesn't.
still be
It's
right.
not wrong.
Okay.
Yep. But if you take out terms when it's not when you're not supposed to, then it becomes
Then it's
incorrect.
bad.
Yep. Is that making any sense? You can also look at it from the truth table perspective.
As a C. I don't know, like, I'm not getting the, like, if this is true and that one's false, then it's true. I don't understand that logic.
But it works out in algebra as well. So if you look at one of the previous slides, I showed the algebra. Okay, so when you look at the algebra term, okay, so you can see that A is the one that has 3 terms, and then AB is the one that has A has 3 terms, right? B is the extra term.
Okay.
And because we are looking at the disjunction of all the conjunctive terms, so we're basically focusing on A plus AB, or A or AB in this case. Is that okay? So when you look at A or AB, is it okay to say instead of A, you just say this is A, or A and true?
Okay.
Is that okay? So the identity of conjunction is true, just like the identity of multiplication is 1. Okay, anything times 1 is that thing back, right? So anything and true is whatever you start off with. So there's no problem by multiplying it by 1 or ending it with true. Is that okay?
Okay.
So now you say, oh, we got A something, we got A something here, so we can factor out the A and then just leave behind the 1 plus B on the other side. Okay? So now we have A and true or B. Is that okay? But when you look at true or B,
It's just true.
it's just true, so the whole thing becomes true. So now you end up with A and true, which is just A. So what that means is every time you see a pattern like this, with A, which is some number of terms, okay, but the other one has the same terms and then something else, then you can just say, oh, forget the one that is more restrictive. AB is more restrictive because it is harder to make AB true compared to just making A true.
So A equals true.
No, he's saying like
Look at it.
something by itself is itself. And
Yeah.
then, but that is A and something else. And the fact that it's a conjunction requires B to be true, and that's restricting.
Okay, let me listen to the hear the other question first. Yeah.
I still don't understand why we can't just simplify it down to just not x0.
Okay, so we'll get back to that one.
Okay.
But I want to illustrate in the truth table why AB is more restrictive. Okay, why it is more difficult to make it true. So we use the truth table for this. Okay, A is false, false, true, true. B is false, true, false, true. Okay, and then we look at the conjunction. And this is a pretty easy one, right? Okay. So how many rows has A being true? 2 rows, right? And how many rows has A and B being true? Only 1. So that means A and B is more restrictive than A. So that's another way to see that A and B is more restrictive than just A. Is that okay?
Okay. This makes sense.
Now, if someone says, okay, but I'm still not convinced that this thing here is the same as that in terms of algebra because I hate algebra. That's okay. It's Boolean, right?
Yeah.
So if it's Boolean, we have this extra tool called
Truth tables. Yeah.
truth table. So work out the truth table. So this is A or A and B, right? So that boils down to A, false and false, which is false. A or false or false, which is false. And then this one is false or false as well, which is false. This is true or false, which is true. This is true or true, which is also true. Oh, notice still how 2 of these columns are exactly the same. This one and this one. Well, since I enumerated all the possible values that can go into A, B as independent variables, and yet every single row between the first column and the last column turned out to be the same. So don't even ask me why in algebra this works out, because in the truth table it works out already. So I'm satisfied. I don't need to learn algebra. Is that working out? So.
Well, he showed me a representation of it in like C, and then it makes more sense.
Sorry?
He showed me a representation of the same logic, but in C, it makes more sense. He showed it like, just gave him variables. I don't know what the rate equals.
Okay. All right. So the other question has to do with why we cannot just say x, not x1, right? Not x0. Okay, so let's go back to that sheet here, and then we try to answer the question. Okay.
That's like
So why do you think we can simplify everything to just not x0? Because it's here? But this is not standalone. Remember, we are combining something from here to something here. Okay, so not x0 is not on its own. When we combine these two, then we can say that this expression is the same as this expression, because we have 2 not x0s.
So if we
Yeah.
don't have any
So-
matching terms like that, we
So, yeah,
can't simplify it.
right.
If we
Okay.
don't have any matching terms, like if we had an x0 instead of a not x0.
Then you cannot use this method of simplification. The nice thing about this simplification is we know that everything in column B is starting off with not x0, x1, not y1. Because that's the way we do the concatenation, right? But if we know that within this column, one of them, at least one of them, reduces to just not x0, x1, not y1, then all the rest they're all gonna be more specific versions of this, because they all start with the same substring.
But doesn't that apply to all of them?
It does. So we can apply the same technique to the other ones. So we look at this one here, and then we say, oh, okay, we have a match because we have not x0 presenting here as the first part, and also here. So when we combine those, then x0 is appearing only twice, which means they can be, one can be removed without changing the meaning of the expression. Yep.
But if we don't have a match, then we cannot do this?
If we don't have a match, then we cannot do this. Correct. Yep. Like in this case, we cannot apply that, but we have a different way to simplify one of the cells. Yep.
Well, we got one zero.
Yeah, it simplifies one.
Oh, no, it's not one.
We can simplify one of the cells. Yes. Go ahead.
So the only way we could reduce to not x0 is if in column A, let's say the fifth term was not x1, y0, right?
Not x1.
So that would cancel out the x1 and not y1 in your column B, row 1.
Which column again?
So in column A, if row 5 was not x1 and y0, then the whole column B could be reduced to just not x0, right?
No.
No.
Okay, so let's take a look at that scenario. Okay, this is just a hypothetical scenario. What do you want to put here?
He's saying put not x1 and y1.
Not x1, y1.
And can it now all be reduced to just not x0?
No.
No.
No, because you have to expand the terms out first, then you can see whether you can simplify or not.
So it just goes to 0 in that case.
Sorry? Yeah. So some terms can be simplified to 0. Okay, so let me just kind of go back to where I left. Oops, where I left off. Okay, x1 not y1, and this one, the entire column, the entire column C is just that. Now this one is special because we cannot apply that special way to say, okay, this whole column collapses to one particular expression, because we have x1 not y0 not y1, and we don't have any one of these terms matching here, because you have to match the polarity as well. Okay, so there's nothing we can do to really simplify the entire column like right away. So we have to actually carry out each one individually. So the first one is just going to be not x0, x1, not y0, not y1. I'm just reordering the not x0 to the beginning because I like the ordering, so that makes it easier for me to look for patterns. The second one can be canceled out because we have a not y0 here, and yet we have a y0 here. So when you look at the actual product, we have not y0 and a y0 here, and when you have the term and its own negated term in the same conjunction, it is always false. So this one is simplified to false. Is that okay? And then the last one cannot be simplified. Well, this one can be simplified a little bit. No, I take it back. It cannot, because these three terms have nothing to do with Cn. So there's absolutely no way to simplify this one. So we just have to copy the entire thing. So x1 not y0, not y1, and C not Cn. There we go. Okay. Oh yeah.
Oh, no, never mind.
No, x1 is not negated. Yep.
So are we gonna let that zero hang around just in case it multiplies?
No, I just want to put a 0 here to let myself know that that cell is factored in. And then the last one, okay, so look at this one here. It does not share anything, so we will have to work out the entire thing. So this becomes not x0, not x1, not y0, and y1. And then this one here can cancel out because of the not y0 in here, and then the y0 here, so it becomes false.
So only the first term you're looking for something to match with the term with the first column.
What?
So like E1, the term that's in there, you're looking for something in there to match with anything in the column of A?
I'm looking for something here that matches exactly in here.
Yeah, that's what I said.
Okay, like in this case here, we have not x0 and we have not x0 here. That's what I'm looking for.
So he's wondering, why didn't you make that a 0?
Huh?
E1 that matches anything in column A.
It does not.
That's what you're looking for, though,
Right. But because it does not, I cannot do that quick trick and just say, oh, the whole column, it becomes this. Okay. So this one, I don't really have a way to simplify either, so I just have to copy the whole thing. Not x1, not y0, y1, and not Cn. Okay. Now, it doesn't mean that I'm done, okay? This simply means that one particular simplification does not work. So I look at all of these terms and now I say, okay, can we simplify this a little bit more, okay? So you look for, terms that reappear multiple times. So let's see. No, this one. I see one. See how this and this are related?
I see two.
Yep, go ahead.
For the second expression in column E, how did you get 0?
You mean this one?
Yeah.
Well, this one is corresponding to this one here, right?
Yeah.
See how we have a not y0 and a y0 in the same conjunction? Yep. So that's how we can turn it into a false, because when you have the negated and the non-negated version of the same pin in the same conjunction, then one of them has to be false, and that's why the whole thing will become false. Question?
No, I said another one.
Okay.
I see two up there now.
Okay. So this one and this one are related because you can see how not x0, not x1, and y1 are in the same expression here. Okay, this one has just an extra not y0, so this one can be taken out without changing the meaning of the expression. So you saw something else?
Yeah, you just shift two, and you're right there. Not x0, no, up, to the left, down,
Just don't
there.
switch
I wasn't even thinking about that. So not x0, x1, not y1.
And
also
compared to
here,
this one,
there.
yep, you got it. So we can take out these and take out all the zeros, so it's not as confusing. So now we have 4 terms left. Now it is true that this may not be the most optimal path to help to have terms reduced, as you mentioned earlier. But this is a very mechanical process. You take the result of distilling all of these cells. You take these and you make these into row 1 of the next spreadsheet, and then copy the other ones to become column A, and then you do the same thing again. You just keep doing this until you're done. So this is a tool that I have made for myself that I felt, hey, this really helps a lot. Because when I'm copying and pasting, sometimes I forget, sometimes I copy wrong. This kind of helps to reduce the possibility. It doesn't eliminate the possibility of mistakes, but it really helps to reduce the chances significantly. Is that okay? Sort of? Does everybody understand at least the general mechanism of what I'm doing here? No?
It's really resourceful.
You say that was such zeal and excitement.
No, I mean it makes life a lot easier.
Well, and that's basically just using existing tools. But if you don't know how to use a spreadsheet, you can use a C program, right?
Yeah.
A C program, because all you're doing is you're reading 2 arrays of strings, and then you're making a cross product, and your quote-unquote product is basically string concatenation.
That's how I eliminated some. I used logical operators in a C program and just plugged and chugged, and I'm like, oh, I could cancel these out because it will always give me true or false depending on only the first statement.
Yep, and for those of you who learn, other scripting languages such as PHP, Perl, or Python, it's even better because in those other languages they can do a lot more by in terms of matching terms. So it can even do some of the simplifications that I did here.
Wow.
But that's in C is a little bit harder because C doesn't support hashes, for instance, and that can really be helpful in something, doing something like that.
You just define how a function to do it.
Yeah, but you can at least do the same thing as concatenation in C and just print out all the cross products. I mean, that's something that you can do.
Is this due at midnight or by class?
It's due right before class because I don't want people to miss class because they keep working on a homework assignment.
Wait, this wasn't due this morning?
It's due this morning.
I was asking.
Oh, this was
I turned it in. I'm good.
Okay, so do you guys want me to finish this, or are you guys relatively satisfied with what I have shown up to this point? Okay, it's good. Okay, so let's take a look at your new homework assignment, which is this one here. Okay. Oh wait, I haven't exposed it yet. It's a binary subtraction and. No, No, that's not it.
Don't give us a horrible solution.
It's a subtractor. I think I forgot to change the name, that's it.
Well, there's one that you didn't have shown that was called binary subtraction.
No, this is the one.
No, that was, I think that was a reading material.
That's more like reading material, you know. Well, you guys can do that too. That one is an easy one. Okay, so this is once again, this is a 2x2 speedy subtractor.
Well, I mean, but now, if you did that last
It's
one,
almost the same thing, and it's due 1 week from today. Okay, so let me save this first. Change it so it's showing. Okay, it's all showing. It's good. Okay. All right. So when you look at the description of this homework assignment, it is almost exactly as the other one because I copied and pasted.
Except that it says 3 bits. I know it's.
I fixed it. Yep. But it's basically the same thing, except this time we're doing subtraction. So what is the difference between adding and subtracting?
Instead of a carry, you've got to borrow.
Instead of a carry, we have a borrow, and
Borrow's
the
a lot
function for the
easier.
borrow is different. It's slightly different, right?
It's easier.
Yep. Go ahead.
Well, it's only the two terms.
It says x0, x1,
That's when you stack them. It's because you were.
Yeah.
Did he ever give us
Yeah,
a formula for
So
it?
you only go.
Borrow
The other side
is
I was at
not
the
X and Y. Yeah.
Did he show this in class?
Briefly.
Oh, okay. 'Cause I don't
It,
remember
it
much
has
of
the
it.
same structure
also in
as
the
your
notes,
4-bit
so-
adder.
Yeah.
Basically, you're
Oh, really?
making
I have my own
template.
note there. I'm wondering if there's more, but.
Okay, so you're basically making a template for a 2-bit adder, and then you make 2 instances of the 2-bit adders and connect them in a way so that by combining the 2-bit adders and a constant, the whole thing becomes a 4-bit adder. So it's the same structure, but the expressions obviously will be slightly different. But in a way, it's kind of nice because you can actually reuse some expressions a lot more than the other one, and I'll show you just quickly why I say that. Okay. Okay. I'm just going to draw this on the whiteboard here. Okay. So when you look at the carry flag, okay, the carry flag is just xy. Okay. When you look at the result of addition, now remember the R function is the same whether you're adding or subtracting. So that means if you keep your work for doing the 2x2 adder homework assignment, you can recycle some of those.
Like copy
Okay.
paste him.
Some, not all. Okay. So remember this, right? Okay. So remember, the result function is the same for subtraction. Okay. So that one does not change. What changes is how we define the borrow flag, right? The borrow flag is basically indicating when do we need to borrow when we subtract y from x. Okay, this is talking about x minus y. And the only time you need to borrow is when x is a 0 and y is a 1. Right? So how is that going to help? Well, it really helps because if this thing is bothering you because you spend a lot of time to work it out, it's using the same thing here.
So can you cancel those out?
Well, they don't cancel out, but you might find that something that you work out because you have to work out the R is something you can recycle in B and vice versa.
Oh, okay.
Whereas for addition, you cannot. Because for addition, you only have C and R, and C is just a plain conjunction, and then R does not reuse a conjunction at all. So there's no way you can actually recycle or reuse some of the derivations that you have done. But for subtraction, you can because this is the same thing.
So once you find R for the right side, you can recycle that.
Exactly. If you see that, oh, okay, we are doing the same thing, and you work out one already, you can just plug it right in. So that's why I said a subtractor is in a way easier because you can reuse some derivations and expressions.
Yeah.
All right, but now that you know the tool that I'm using, okay, and just the techniques that I use, it's take it with a grain of salt, sea salt, whatever, okay. Himalayan salt. Okay. I'm not saying that you should do it that way. I just find that for myself, it really helps because yesterday I was spending like a few hours, and I kept making like stupid mistakes. Forgot to copy an exclamation point, and then mess up the whole thing. And go like, oh man, I have to go back and track it down. But the nice thing was I recorded everything, And I was able to follow my own steps until I go like, oh no, this doesn't follow that. So that's, it's a repetitive process. Everybody's going to make mistakes. So the question is, can you contain your mistakes so they're easier to find? That's the only thing. All right. So are we good? All right. So we are leaving here. I'll give you guys, okay, we're stopping the class 5 minutes early, so I promise that I will make it up later in the semester. I might have made it up already if you ask Bob, the next professor.
Right, isn't it?
So I'll go ahead and wait for you guys over at the lab, 128. So if you want to get a head start on the subtractor, or if you have questions about the adder, we can deal with those questions over there. Until 11:50. Today.
Yeah.
PST.
I have a quick question.